Now I will talk about drive to the drum on Autoconer 107 and 138. Unique feature of the drive then was an individual drive to each drum. In BC spooler and in the non-automatic winding machines, all drums are mounted on a common shaft and are driven by a common motor. So the drum is rotated continuously. Whenever winding is to be stopped, the drum rotation does not stop, but package is lifted out of contact with the drum. Whenever winding is to be restarted, the package, which is stationary, is placed on the drum, which is rotating at full speed. This has certain drawbacks. So to overcome these drawbacks, the drum drive on Autoconer 138 and 107 has been improved. Each drum is driven individually. Whenever yarn breaks or supply package exhausts, the drive to the drum is stopped. Whenever winding is to be restarted, the drum starts from zero speed, that is from stationary state. Other feature of the drive is that whenever the drum stops, the package is also simultaneously lifted out of contact with the drum. So whenever yarn is absent in the spindle, drum drive is cut off, drum is braked, and package is also lifted out of contact with the drum, and package is also applied with the brake. This is very advantageous in improving the lay of yarn on the package. If such drive is not given, and if the drive as it was on the earlier other machines, that is drum rotates without any stop, then that is likely to cause disturbance in the lay of yarn on the package, which can be detrimental during its unwinding. Other important feature what you have to note here is that drum is not rotated at constant speed, but the drum speed is made to rise, fall periodically in order to break the ribbons. Ribbon breaking methods working on skid principle are very well known. So to break the patterns, the drum speed is periodically increased, decreased, and this brings about some slippage between the package and the drum, and this helps in breaking the ribbons. So the drive here is also provided with a facility whereby the drive brings about periodic rise and fall in the drum speed. Now this is the animation of the drive. Let me run the animation. You have a look at the animation first. Now, the machine carries a drive shaft running across the length of the machine. So this is the view of the machine. So this machine has got a shaft that extends across the whole length of the machine, and this shaft carries number of drive pulleys. That is what I was trying to tell you. And this shaft is driven by a common motor. So there is a common motor here. That motor drives a shaft, and that shaft carries number of drum drive pulleys. One pulley for each spindle. So if this is a 50 spindle machine, then the drive shaft will have 50 pulleys on it to drive the 50 drums of this machine. So this shows drive shaft pulley. So this drive shaft is driven continuously. So this drive shaft is driven continuously, and because of that, this drive shaft pulley is also rotated continuously. This drive shaft pulley drives a friction roller. So drive shaft pulley through physical contact rotates a friction roller, and this friction roller by physical contact drives a pulley on the drum, and drum drives the package. So this is a mechanical drive from drive shaft pulley to friction roller to winding drum, and thereby the package is rotated. Thus, it used to be a mechanical drive on Autoconer 107 and Autoconer 138. As seen in the animation here, if the drive shaft is rotating at constant speed, the drum would also rotate at constant speed, but for anti-patterning, it is desired that the drum speed should periodically rise and fall. So let me show you other animation how it is done on this machine. So just observe this animation. What you would notice here is that this friction roller is given a movement, as you can see, so that its contact with the drive shaft pulley is made and broken. So friction roller is not in continuous contact with the drive shaft pulley, but it is given a motion so that contact is made and contact is broken. This will bring about the rise and fall in the rotation speed of friction roller and thereby that of the drum, and that will bring about some slippage between package and the drum and would break the ribbons. So this animation is added with how the anti-patterning is provided on this machine. So it is by giving the movement whereby the whole friction roller bodily moves so as to make and break contact with the drive shaft pulley and bring about the rise and fall in the rotational speed of the winding drum. Now let me tell you how the drive to the drum is stopped whenever yarn is absent in the spindle. So it is very simple. If I want to stop the drive to the drum, this friction roller should be moved away from the drive shaft pulley so that it doesn't contact the drive shaft pulley. Thus, the drive is disengaged here by moving this friction roller away from the drive shaft pulley, and at the same time the drum is applied with brake. Now, one more thing you have to note, that if I stop the drum but if the package still rests on the drum, then package will not tend to stop immediately. It will continue to rotate because of its inertia, and in that case there will be some abrasion between the package and the drum. Plus, if package is rotating and drum is in stopped condition, then traverse will stop and this may wind the yarn at one place. Therefore, on this machine, whenever drum is stopped, simultaneously this package is lifted out of contact with the drum and package is also applied with the brake. So when spindle is stopped, the drum stops, package is lifted out of contact with the drum, and package also is made to stop by applying brake on the package. You please note this in the animation that I am going to run now. So observe the animation, drive is going on. The moment the yarn breaks here, see how the, see that the breakage took place and the winding drum is stopped. Friction roller is no more in contact with the drive shaft pulley. Brake is applied on the drum. Package is lifted out of contact with the drum and brake is also applied to the package. So package is also stopped. Let me run this once more. So note that when the drum is stopped, package is stopped, but the drive shaft pulley continues to rotate. So let me show you this animation once more. So note that after the drive here is stopped, the drive shaft pulley still continues to rotate. Let me explain you what is the advantage of individual drive to the drum. If drum is not given individual drive, in that case, to stop the winding, the package is lifted out of contact with the drum, as can be seen here. So this package is out of contact with the drum. At this point, drum is rotating at its full speed and package is stationary. After rejoining of the ends, the package is lowered on the drum so as to start winding. The package is lowered down as can be seen now. Now, just when you do this, the situation is that drum is rotating at full speed and package is stationary. So package will take some time to attain its usual surface speed. So you know that in surface drive, the surface speed of the drum and surface speed of the package both are same. But initially, in the acceleration phase, the surface speed of the package lags behind the drum and there is abrasion between drum and the package. This abrasion is not desirable. it can be detrimental to delicate yarns. The other problem this causes is that it disturbs the lay of the yarn on the package. How? Now, this is a vector diagram. This shows the surface velocity vector and this shows the transverse velocity vector. So, in this figure, the surface velocity is tangential to the package, whose magnitude is pi dn, where pi is the constant as you know, d is the package diameter and n is the package RPM. This is the transverse speed of the yarn. Now, when the package is put on the drum, the transverse speed is attained immediately because the yarn starts following the grooves of the drum. But initially, the surface speed is less than what it should be. So what problem this causes? Let us see. Now, this vector diagram shows the situation in usual drive condition, where this is the surface velocity vector, this is the transverse velocity vector, and this is the winding velocity vector. This is the coil angle. Now, this is the case when usual winding is going on. This shows the situation at the start. So, at the start, the surface velocity vector is smaller because package does not attain the same speed immediately. Transverse velocity vector remains the same, but surface velocity vector is smaller. Because of that, the angle at which the yarn is wound, that is this coil angle, becomes higher. So what you have to imagine, that if this is my usual coil angle, say, and if yarn is laid at greater angle, then this will give the problem during unwinding. Thus, the lay of the yarn is also disturbed. So, disadvantage of continuous rotation of the drum is that it causes the abrasion between the drum and the package during the initial phase, and it also increases this coil angle in the initial phase. So, this can be avoided by giving individual drive to the drum. Drum drive on automatic winding machines require one more feature, that is, the drum is required to be rotated in opposite direction during splicing. So the hollow arm, it moves closer to the winding package and the package is rotated in the reverse direction so as to pick up the yarn. Now I will run the video and you try to have a look at it. So see, this is the splicer and you see the two arms. Again you see you can see it again. So this is the arm that moves closer to the package, and you note here that the drum is rotated slowly in opposite direction. And the end is found. See it again. Thus, it is necessary to rotate the drum in reverse direction at slower speed when the splicing cycle begins. So the drum drive must incorporate this feature in it. Now, let me explain you how the drum is rotated in reverse direction during splicing cycle. We have already talked about a drive shaft pulley earlier. Similar to that, there is one more shaft, that is a reversing shaft, and this shaft also carries several pulleys. So there is one pulley for each spindle. This pulley rotates in reverse direction. So this drive shaft pulley is rotating in anti-clockwise direction, whereas this reversing shaft rotates in clockwise direction and at slower speed. You know that during winding, the friction roller contacts the drive shaft pulley, but for reversing, the friction roller is moved down so that the friction roller contacts the reversing shaft pulley, and because of that, the direction of rotation of drum is reversed and the drum rotates at slower speed. Now, let me show you how this happens through an animation. Now, this is the arm that has come. The arm picks up the yarn and it places it in the splicer. Let me run it again. So the drive is now through reversing shaft pulley. So package is rotating in the reverse direction, end is formed, and the arm moves down, placing the yarn in the splicer. Again you can see the animation. One more times I will run the animation. So this is the reverse drive to the drum and finding the end. Now let me summarize the drum drive through animation. This shows the situation in stopped condition. This is the friction roller. In stopped condition, the friction roller is not touching the drive shaft pulley as well as reversing shaft. So it is not getting drive from any of the pulleys. Drum is applied with the brake, package is lifted up, and therefore the winding is not going on. So this shows the situation in stopped condition. Now let me show you the situation for driving the drum. For driving the drum, the friction roller will contact the drive shaft pulley and the drive starts. So this shows the situation during the winding operation. Now, to add to this, for anti-patterning, the friction roller contact with the drive shaft pulley is made and broken. So now I will switch over to the anti-patterning situation added over this drive. So this is the drive situation in anti-patterning. Now let me switch over to the situation for reversing. So for reversing, the friction roller will contact the reversing shaft pulley and the package will start rotating in the reverse direction. So now I will switch over to the reversing situation. So now the drive is through reversing shaft pulley and the package rotation is reversed. Let me repeat it again. Drum in stopped condition, drum drive plus anti-patterning, and this is the reversing of the drive.